So using place value with whole numbers is our very first topic. You can see here we've placed the first few digits on the number line. We refer to this as the number line, but it's more like a number spectrum. You can think of it this way. And it gives us a relative sense of the value. So smaller or larger numbers get placed in different places. We can see in the top corner here that we actually differentiate between two different sets of numbers. There's the counting numbers, which are what you probably are used to using to count with your fingers, right? These 1, 2, 3 digits, the ellipses here suggest that it goes off towards infinity, right? There's an uncountable number of counting numbers. It goes on forever. And then the other list that you see here is the whole numbers, which is essentially the same list, except that it includes 0. So the whole numbers are 0, 1, 2, 3, so on and so forth. And our spectrum here at the bottom, or our number line, however you refer to it, is showing the first few digits there. And again, that representation shows that the larger the value is, the further away from 0 that it is, right? Now, we can think of this in terms of physical objects. Let's say I have a single stick here, and over here I have 2 sticks. Now, the sticks are physical objects. We can say that they correspond to numbers, but essentially it's just an item that we can count. The object is almost irrelevant. I could say that we have 1 apple and 2 apples, or 1 car and 2 trucks, right? They're all vehicles. We can still count them. And so there's this sense in which they have a relative value as far as the number, but not any other characteristic is really quantified by saying that, right? So we say that we have 1 truck, but that is fewer vehicles than the 2 trucks that we have placed together here. So the relative sense of absolute value is shown by this type of spectrum. This number line is really useful in making computations as well, as we'll see a little bit further down the line.